Let us try to solve this limits. Okay, when you substitute x as -2, so this will be 0 by 0, so which is indeterminate form. So let us apply by applying L'Hopital rule. Okay, let us apply that. So differentiate the numerator with respect to x. Okay, so limit d by dx of tan pi x by d by dx of x plus 2. Okay, so which leads to pi secant square pi x. Okay, so limit x tends to -2 pi secant square pi x. Okay, on the numerator, and denominator with respect to x, I get 1. Okay, now let us substitute x as -2. So this is pi secant square of -2 pi. Okay, secant square of -2 pi. Now this is equal to 1. So you get this as pi. So that is the solution. Okay. Okay. Now let us try to solve limit as x tends to 0. Okay. A power x minus b power x by x. Okay. Now when you apply x as 0, right? So what do you get? Okay, when you put x as 0, you will get again 0 by 0. Okay, which is again
Yes, sir.
an indeterminate form. Okay, now again by applying L'Hopital rule, okay, by applying L'Hopital rule, so limit as x tends to 0. Okay, so d by dx of a power x minus b power x by d by dx of x. Okay, now differentiation of a power x will become a power x log a, okay, minus differentiation of b power x will be b power x log b, okay, by 1. Okay, differentiation of x, okay, which now substituting x as 0, so we get this as log a minus log b, because a power 0 which is 1, b power 0 which is 1. Then again we can write this as log a by b by applying logarithm law. Okay, so let us solve another problem. Yeah. So again, a limit x tends to 0, x cos x minus log of 1 plus x by x square. Again, by substituting x as 0, you get 0 by 0, which is an indeterminate form. Okay, again by applying L'Hopital rule. Okay, let us apply that. So 0. So this will be x cos x, that is cos x minus x sine x, okay, minus 1 by 1 plus x, okay, by 2x, okay. Okay, now when you put x as equal to 0, still I get this as 0 by 0, again in determinant form. Now again differentiate the numerator and the denominator. So let us differentiate it. Okay, so cos x and sin x, this will become 2 after simplifying, sin x minus x cos x plus 1 by 1 plus x whole square. Okay, this will be by 2. And now substituting x as 0, you get 1 by 2. So, so we have h tends to 0. So, since h is tending to 0, so we can write 2h also tends to 0. So let us put that. So limit 2h tends to 0 and e to the power of 2h minus 1. So I have h, so I'll multiply and divide by 2. Okay, I have done multiplied and divided by 2. Okay. Now this would result to 1 and this is 2. Okay, which is equal to 2. Okay, so let us try to solve this. Okay. Now let us assume as 1 plus x as y. Okay, so that now x, when x is 0, okay, so y will be 1. Y will be 1. Okay, y tends to 1. Y will be 1, that is y tends to 1. Okay, now change the limit. Limit y tends to 1. Okay, so we get y power 5 minus 1 by y square minus 1. Yeah, okay. So in the numerator, you'll have this as 6 into 1 power 5 by, I mean, this 1 minute. Okay, so this will be 5 multiplied into 1 to the power of 4, right? Divided by 2 multiplied by 1, right? So this will be 5 by 2, right? So we get this.
Yes.
So let us find the value of a for the given limit. Okay. Now, okay, we know that limit x tends to a, x to the power of 7 and a power 7 by x minus a, right? Let us substitute x as a. So we get that as a power 7 plus a power 7 by a plus a, right? Which is equal to 7, right? Okay, so this leads to 2a power 7 by 2a. Okay, again, further you simplify it. So after simplification, a power 6. Okay, a power 6, which is 7. or we can write as a as 6 root 7. Okay, so this
Yes, sir.
is the value of a. So let us prove that limit x tends to 0, e power x minus 1 by x is equal to 1 to get this result. Okay, okay. Let us see the proof for this. Okay, now limit x tends to 0, e power x, which is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on, right? So minus 1, right? E power x can be written as like that. So here plus 1 and minus 1 gets cancelled. Okay, so limit x tends to 0. So this will be x plus x square by 2 factorial plus x cube by 3 factorial and so on, right? This divides by x. Now let us take x as common. Okay, so we can cancel out x, and then once we do that, okay, we can put uh, x as 0. Okay, so this will be 1 by x by 2 factorial and x by 2 factorial, and this will be x squared by 3 factorial and so on. Okay, in the denominator. So we'll cancel this. Yeah, so now when you substitute x as 0, so you'll get only 1, and then rest all terms will be 0. So hence we have proved that the limit x tends to 0, e to the power of x minus 1 by x, which is equal to 1. Okay, we'll solve this now. Okay, so limit x tends to 0. I'll take x as common. So this will be a plus cos x, okay, divided by this I'll put b sin x. Okay, now what I'll do is multiply and divide by x here. Okay, I'll do this. Yeah, and then let us apply limit in the numerator also and in the denominator. Let us separate that. So this will be x, right? So I can cancel out 1x here, right, with this. Okay, so I'll be having a plus cos x, okay, in the numerator, okay, divided by the denominator. I'll have x uh, sin x and b, right? So b sin x by x, right? So we know that sin x by x and its limit is 1. Okay, and for the limit as x cos as x becomes 0, we will get cos 0, which is 1. So in the numerator you will have a plus 1 divided by b. Okay, so that is the final answer.